with a 5-5 timer. The 5-5 timer IC was first introduced around 1971, and it is the most versatile circuit that appeared in around 1970s, right? So 5-5 timer provide a circuit designer with relatively cheap, stable, and user friendly integrated circuit for both monostable and astable applications, right? So let's see the application areas of 5-5 timers, right? So we can use 5-5 timer to design monostable and astable multivibrator circuit. The second one is waveform generators. The third one is burglar alarms. And we can use 5-5 timers also in measurement, process, and control unit in control engineering, right? So, and also 5-5 timer is the most common circuit that can be used for traffic light control. And you can find also it's very important for automatic battery charger. So what I've said before, it is the most versatile integrated circuit in electrical engineering. So what inside 5-5 timer, right? And you can see from this simplified block diagram, the 5-5 timer has two comparators, right? Comparator one and two here around, and it can also has SR latch, and it consists of discharging transistor here, discharging transistor here. So, when you see the pins there will be threshold, trigger, discharge, VCC, V out, and the ground pin is there. So there are pins that are related with five timer. So we'll see how to use this 5-5 timer for monostable and astable multivibrator or circuit design. So let's go back to my PPT. So it consists of two comparator, SR latch and Q1 transistor, right? So we can use 5-5 timer to generate the, what can I say, astable multivibrator. So related with multivibrator, it will generate rectangular wave anyway, rectangular wave having T of high and T of low by using this equation. You can see the equation there. To find the time on or high, you can use 0.694 in the bracket R1 plus R2 times C external. What those are, we'll see on the lab sessions, right? TL equals to 0.694 times R2 times C external. And anyway, duty cycle, simple. You can calculate with R1 plus R2, the whole over R1 plus twice R2 times 100%, right? So, and frequency related with 5-5 timer, you can find with this equation, right? F equals 1.44 the whole divided by R1 plus R2 times C external. That is the beautiful equation for to find frequency of oscillation of astable multivibrator, right? So let's go to the lab session. So we can test how it can generate a stable multivibrator by using LT spice. So let me go to my computer on what I've said, LT spice. So LT spice is something like this, and we can use LT spice 8. So to find the components, here, I can click here, component there, and I will click there. So to find 5-5 timer, I think it can, or we can find it in miscellaneous. And here you can see NE555, right? Okay, can you see it? Fine. So when we see the pin diagrams on 5 timer, you can see pin one or the first one on the left side corner. You can see after this notch. So GN, the ground is here. The second one is trigger. The third one, or pin number three, is the output. And the fourth one is reset. We can use a reset pin if we don't, we can connect a reset pin with something VCC. And if we don't use reset pin, right? So you can see here on the top pin number 8, which is VCC there, discharge pin is there, threshold pin is there, control voltage is there here, right? So when we want to change frequency of oscillation, f of, if we want to change f, right, we can use any voltage level here to change frequency of the oscillation for 5 times. So let's minimize it and let's try to build simple circuit, right, to generate a stable multivibrator, right? So what we need on that, we need power supply. What can I say? Let click V. We need a voltage, right? And we need a ground. Ground is there, right? And we need a ground. The two resistors R1 and R2, and we need C external, right? C external, C external, and it's assigned C1. So let's try to connect the 5 timer to generate a stable voltage level here there. So let's move here. Okay, just connect and discharge. Bring here discharge pin, connect, trigger, come here and connect here. Threshold should be shunted also. Threshold should be shunted here. And fine. Good. We can connect like this. VDD there, output can be collected from here. So let me make circle like this. We don't use a reset pin, so we can connect it to the power supply. And also VCC should be connected to the external battery or power supply. When we are configuring for ST multivibrator, so you can connect here, ground we need here, and let's do make this 5 volt. Okay, let's do this guy almost 10k, 10k, and this guy almost I can do that 50k. Let do 50k, and this guy C external, C external, 1 micro, 1 micro, or 10U. Can I make 10U? 10 micro, 10 micro. Good. So we can collect output from pin number 3 out, V out here. We can put V out on this, on the pin number 3. Fine use. So let's try to do simulation, right? Can it generate rectangular wave, right? So let take this one for 2 seconds, right? 2 seconds, 2 seconds, right? Fine, and let's draw the output. Wow, wow, fine. You see, it will have off time here and on time here, right? And off time here, on times here. So to find on time, you have to remember the equation, right? So equation, you remember T on time and off time is there, and the T on frequency almost 1 hertz, right? Almost 1 hertz, around 1 second here. And on time is around 0.57 something second, right? And off time, uh, from here to here, let's try to do something, right? Cursor, one, okay, cursor, one and two, okay, one and two, let's make it okay. So on time, this guy, right? Cursor two, cursor one and two. So cursor one, I think the cursor two, 9698 point something millisecond, almost 1 second, right? And this guy, 55055 0.03 something millisecond. So almost 5.5 0.55 second, right? 0.55 second.